Hey everyone, welcome to my channel. In the last session, we read a brief information about the intro about Spark session, Spark learning we started, but the entire video was without a video, so that's why I just want to go through what we have learned in the last session in the from the same Chat GPT window. But right now, I'm going to share the entire details. Entire screen I'm gonna share. Let- We could able to see the window. So now let's start going back to the same chat GPT prompt, and we will try to learn end to end from the last session. So consider this as an overview, and after that, we will we will continue our learning with the same chat GPT prompt. So yeah. So the initial thing, what I have specified in the, I created uh, one. This is one folder I have created in my ChatGPT account, and there is one session I have created, one session like or one chat I have created with the name of my name like Spark Prep. So so after that, I gave this information, which is learn Spark coding end to end, test me, improve my knowledge. I want to learn step by step. Okay, so once I gave this information, it's like it's treated it as a like a Spark boot camp. So it gave here is the path. Is a path, the GPT specified a particular path, so that based on my background, like I am a data engineer. I have a certain background knowledge about how the mm, data engineering flow works. Whether Spark is as Spark is um, a good data engineering platform with distributed computing. So it gave a few insights. Like how the path will go. So it start with Spark basics, and the mental model and data frame basics and reading data. Select filter with column cast, null handling and basic functions, group by and aggregations, and of course joins and window functions. Spark SQL, performance tuning basics, and partitioning and shuffle and cache, real ETL patterns and structured streaming, um, and interview level practice rounds. So these are the basic information it has given in from the last session. If you wanna watch the last session, you can just go back to the same channel, whatever you have already in, and you can able to learn that. Next, so so there is a pattern, specific pattern it has specified, which is a quick connect, one small code is example, and one question for you, and I correct and level you up. Means like it's a interactive session. I may use this in a voice mode as well, so that I will give my answers, and prompt will GPT will analyze it, and if there's any issues in that, and it will correct it, and it will make me understand end-to-end concepts. So, so core idea, it's like a Spark is a distributed processing engine, a very simple mental model like driver, executor, partitions, and transformations and actions. Let's start with actions. Actions are the ones which will trigger the entire execution. So that will an action will trigger to start the program, and that will be with some transformations, and that transformation will be executed in that. While executing that, it will create it will use the concepts called partitions, like means since Spark is a distributed computing platform, it will have multiple drivers and executors, like driver and the corresponding executors, and of course in the each executor will create some partitions to to differentiate, to segregate the data in different chunks, so that it will process end to end in a parallel computing manner, so that the performance will be efficient. I mean, while just solving this data engineering solutions. Okay, Spark does not do the work immediately for transformations. Of course, the lazy evolution concept you might have already aware. So in a one sentence, if you want to understand the lazy evolution is like until you trigger an action, it won't start anything. So whatever the execution will actually start from the action. So is there are few like show, count, and collect. So once the action is triggered, and then it will create allocate resources and it will start triggering the corresponding instructions need to be performed one after the other. Okay, so it gave an example until and unless show is done, until and unless show is uh, until you enter the show, which is a action. So until you give an action, so it won't perform the above instructions. So that's what it is. So that's what the explanation is all about. And now your turn. One question. So in Spark, what is the difference between a transformation and an action? So I mentioned it's like when action progresses, then only the transformation will happen. So the modification transformation is the modification of the data, but it won't happen unless action is performed. So it says good, but improvement needed. Like, okay, transformation is a modification of action, but transformation does not actually modify data immediately. So yeah, until an action triggers, it won't modify anything, it won't change anything. So that's what it is saying. And after that, it gave another question. So no, here the answer is no, because the Spark does not read the file, because there is no action in the entire chunk of code. So it says read.csv means it is reading a CSV file, and filter means it's filtering the whatever the file that it's supposed to read, and in that select name only, it select the name column in it. So uh, but the until the action is not added to this particular chunk of code, it won't perform anything. So it will just the code will be visible. That's it. I mean, it won't do anything behind the scene. If you um, yeah, so that's why the no is a correct answer. Why no means because all are the transformations, there are no action is there. So that's why the lazy evaluation is the main thing. So what happens internally is Spark framework will prepare a DAG, directed acyclic graph, like means the flow, what it needs to be done end to end defined. So until an action till this, and it needs to be added with some action so that it will start triggering everything and start executing step by step. So that action is not there here, and of course it won't progress anything. So what so so this is show. Once you added this show, it will automatically start. Okay, now step by step is, does Spark execute only show, or full pipeline, or what are so what I answered is, it will do full pipeline. So yeah, so idea. So let me tighten the wording a bit. So yeah, so as I noticed, I have a problem of um, wording issues. So that's why, that is the reason I had started the channel, so that whenever I'm learning something, I want to learn in a live stream only, so that I'll articulate and improve myself, and of course mm, any further improvement needed, I'll get some idea from you guys. So yeah, if anybody watching this video, or they just help me to improve myself as well, and of course, I mean, any suggestions also acceptable. So next, so the better version the GPT gave is, when df3.show is called, Spark execute the whole lineage or pipeline, just not the show. Okay, order, right? Read the file, apply the filter, and select specific column and of course return the result. So but the return the result, that necessity based execution, I can say, like that's why it called a lazy evaluation. So necessity, once the necessity is there for an action, so then only it will trigger all those transformations. So one important correction, you said thread. Yeah. Next question here is, why does Spark split data into partitions? Okay, Spark, since Spark is a distributed computing engine, so if you partition the data, right, the processing will be parallel. So it perform a parallel execution. So Spark will split those things into, here I should not mention things, split those data into multiple partitions. That's a solid answer, exactly right direction. Okay, and that's a good information from the GPT. Uh, Great clarity, your idea refined. Spark splits data into partitions so that each partition can be processed in parallel by different executor cores. More partitions, more parallelism. Each partition, one task. Small upgrade to your thinking to split the data into. It's also okay. It's not just split the data. Fault tolerance and scalability. Okay, so as per the deck, if there is any failure occur in between, it will start recomputing only the failed partitions, not the already succeeded partitions. So that is the best quality of, and of course it can handle the huge data since it's a parallel parallel computing engine. So yeah, of course it is. So each runs in parallel. Of course, it gave a quick visualization of mental model data. So okay, next, each runs in parallel. Now let's test your understanding. Okay. Four partitions, two cores. How many tasks run at the same time? Of course, two tasks. I mean, I gave the correct answer. So since, I mean, like how it is, like two cores of executors, so two cores of executors only available means at a time how many number of partitions are there, it can only start executing two only because two cores are available. So cores means two ways, two parallel ways it can start executing, and after that it will pursue the another two uh, cores, another two partitions, sorry. um, nice. That model. Okay, next, let's look this concept, like four partitions and two cores, only two, of course. I mean, the explanations the same way whatever I have explained, that is the same here it has given. This is called task scheduling in batches. So we need to remember task scheduling here. So based on the course, how many number of partitions will be there, it will perform, it will consider the chunk of data, undergo with certain transformations or an action. So step by step, it will take into consideration like wave one, task two, because the two cores, and wave two, task three, task four will be there. So each partition will be a task here. So that's what it is explaining. Mm, Next, if I increase partitions from 4 to 100, but still have two cores, 50 is faster. Why? Okay, so I was thinking like since only two cores are there, even though it has 100 partitions at any point of time, two cores only there to execute or perform the operations on the chunks of data. So that's was I thought like it's not a good way. I don't think so. It's faster. That's what I said. But there is something. conceptualized by the GPT understanding the Spark is, at any given point of time, if all the cores are busy and performing something, then it's a um, good configuration to execute the Spark code. So that's what it says finally. So not exactly slow only. 100 partitions, so of course, total work split into smaller chunks. So what actually happened is not 50x faster, not necessarily slower, more overhead task scheduling, shuffle, etc. can help in better load balancing. So the takeaway from this is too few partitions is underutilization of that particular environment, whatever we have established. Too many partitions is overhead. Optimal partitions is the balance. So here your system is fully busy by utilizing all the cores, then that can be a good performance, you can say. So even though it is number of partitions are more, number of partitions are less, but the cores should be occupied. So that is the best design you could able to perform in this Spark environment. Okay, now GPT gave an example, which is worst and why. So two partitions, 8 cores, 100 partitions, 2 cores. Uh, which one is best? Which one is worst? It says. So I said first one is worst. I think I said two maybe because I was still under the impression like. So that's why GPT corrected me that but this is where we refine your thinking here. So that's what I mean. The conclusion of this entire information is, irrespective of how many partitions you are doing, irrespective of how many cores you are using, whatever the number of cores you have currently performing an operation, so that needs to be occupied. So then that will be a best thing you can say, even though it is an overhead, but still if more partitions are there and you are performing through a certain limited number of cores, but all the cores are occupied, then we can consider that as a best design. So that's what the GPT is saying. Mm. Next key interview insight is under yeah. So key insights is under partitioning is worse than over partitioning. So yeah, you lose parallelism capacity and you can recover because Spark itself is built for the distributed computing in a parallel manner. So that's the best you could, you may have the number of partitions, but you need to utilize all the cores. That's the best design you could able to perform. Next, quick check, complete the sentence. Best number of partitions should be slightly more the number of cores. Yeah, that's correct. That's the correct answer. Next, best practice. Number of partitions should be slightly more than cores to keep all cores busy and handle the skew. So this is the best. We may learn about the skew later, but as of now, we'll just understand it as a word. Skew is like it's a component where it measures your performance, measures your program performance with respect to the Spark framework. So yeah, that's what skew is all about. But yeah, we'll learn detail and we'll learn little detail in future about this. Quick reinforcement is equal to core is okay. Slightly more optimal. Best is slightly more partitions than the core. That's the best. Too many is like a overhead, and very too few is the worst. So if you have more partitions, sorry, if you have less partitions, more cores, then it's a very worst design. So you should not be the case. Now let's save the code. Say now let's move to the coding. Important skills. Okay, next we'll start data frame basics. Your real working area, of course, concept. Creating a data frame, of course, spark.read.csv, df spark.es.csv, and the of course the corresponding file name. If you have header is true, and info schema is true, so like schema is available. Mm, this give you a data frame like a distributed table. So data frame is like a table internally, but even though it is distributed with the different chunks of partitions, that's doesn't really make a difference. It is distributed. Mm, it's a table inside. Okay. Then if you want to read a JSON file from path data users.json, how would you write it in the Spark? Don't worry about it. Okay. Hey, before going further, technical area of this, I just want to know what exactly the keynotes in the functional area so that you will have a better idea going forward. So give me all the key concepts before coding itself. Okay. Okay, yeah. Fundamental concepts first, and then we'll learn. We'll go towards coding. So Spark functional core. What you must know before coding is you need to know about driver, executor, transformations, actions. Yes, I understand this. And next, data abstraction. Very important. RDD is the low level, more controlled, non commonly used API, and there is one next is data frame API. Mostly used now. It's a table-like structure optimized by Spark, and because of the Catalyst, Catalyst is a component. It's available in Spark Engine, which will convert the code into um, machine understandable format. So that's the it's like a compiler. Okay, what you will use? It's okay, that's fine. A type specified version of a data frame is called dataset. So maybe we can focus later on this. We need to understand the lazy evaluation as well. As I explained, until the action is not triggered, it won't perform any operations. That's what the lazy evaluation is all about. Apologies for the delay. Yeah. So avoid unnecessary computation, combine operational efficiency. Yeah, it's lazy evolution benefits. DAG, of course, the directed cyclic graph, which will give the entire plan how the program going to be executed, and yeah, Spark converts this into stages and tasks. Okay, transformations types, important distinction. Narrow transformation, of course, wide transformation. Okay, narrow transformations and wide transformations. If anything involves a shuffle, okay, that is narrow. That is wide transformation. If that is not involve a shuffle, then it is a narrow transformation. Like for example, select, filter, and width column is the narrow transformations, and group by, join, order by are the wide transformations. So to understand this so simply is like when you need to do aggregations or any other type of grouping things, it will be called as a wide transformation because when Spark reads the data, it distributes into multiple chunks because it's a group by or any grouping related stuff, grouping related transform function, grouping related transform, or grouping related transformation. Then it will create uh, a then it needs to acquire information from the multiple chunks of data. Then it will involve a shuffle. So that shuffle will be a little costly. So that's the reason it's a wide transformation, you can say. And if it is selecting, filtering, and with column, these type of functions are directly applied on, even though it is applied on multiple chunks of the data, but it need not to collect that information together, or shuffle not be involved in those cases. So that's why it's a narrow transformations. Okay. Next is shuffle. Data moves across nodes, means different nodes, different chunks of a data it needs to perform. So that's called shuffle. You can say it's a very critical concept. Next, costly, because network, disk I/O, and serialization. These are the three concepts that are involved in this. So while shuffling, because when it is moving across nodes, it has to go through a network bandwidth and also the disk I/O. Maybe the data is written split, not data may not all the time written into memory. Sometimes that is written into IO. Serialization, one concept I need to understand a little bit more. So there are two concepts that are pending as of now, which is serialization, and also one more thing is queue. So that is pending. So I'll try to learn that. I'll try to, yeah, we'll learn that go in future. Next, partitioning. Yeah, data splits into chunks, and each partition is one task. Control is a parallelism and performance, of course, and cart list optimizer is the Spark automatically does, and which is uh, reorder operations, pushes filters down, optimizes joins. This is the catalyst functionality. You don't manually need to optimize anything. Just internally, catalyst will help you to make things work in an efficient way. Next, action versus transformation. You are already aware. Just transformation is just a build a plan. Actions only, it will start executing the plan. Next, persistent or cache is like, for example, a data frame. You need to use that multiple times. Then in that cases, you will think about persisting that particular data to the disk or maybe in memory. I'm not sure as of now. There's one more. We have to we'll figure it out. As of now, I'm not sure about it, but yeah, we'll figure it out. Next, fault tolerance based on lineage computes failed partitions. That is one of the feature, because yeah, the DAG itself, once it is prepared, and it will execute step by step. If there is any failure in between any task or any stage, it will continue from that particular stage. So yeah. So now let's check your understanding. Don't keep this. Okay. Next, shuffle and why. Of course, I gave the answer correct. Which has a shuffle in this. It's a group A has a shuffle in a group, because it has to collect from the data from multiple areas. So that's the reason. Let's make sure understand why. Okay. Why does group by clause shuffles? Okay. Step by step. Data is prepared across partitions. Same department values may exist in different partitions. So to count correctly, Spark must bring same keys together. The shuffle will happen from that to this, and of course, it will involve some costliness in this programming. Um, Data movement across partitions equals to shuffle. That's what it called. Quick reinforcement is select. Just pick the columns, no shuffle. Filter, remove rows locally. So no shuffle. Group by, of course, needs data arrangement. So yeah. Now, yeah, till this we have completed. Till this it is completed. So yeah, let's continue further. Okay. Okay. Why does join also shuffles? Okay. I'll answer directly here. Join shuffles because based on the key, it has to distribute that into multiple chunks of a data, or maybe multiple cores. And after that, while matching those values together, it has to do operation in such a way it needs to collect the data again and provide the results. So that is the reason it'll shuffle. So join shuffles. See, okay, let's enter this and we'll see. um, Nice, you're on right track. Let's sharpen it. Crisp interview level clarity, refined explanation. So I'm also currently facing the difficulty, refining the answer in a proper way. So it may take a while for you guys as well. Maybe if you're little bit educated about the Spark, and your answers will be little perfect going forward. So that's the expectation we have. So let's see. So the join causes shuffle because the same join key can exist in different partitions on different nodes. Spark must repartition data by the join key so that matching keys land in same partitions. Then the join is performed locally within each partition. So to remember this simply, uh, so join key can exist in different partitions or on different nodes. So Spark must repartition data by the join key. So it has to collect the data together based on a join key, and of course, so that matching keys land on the same partition. So if A is matching to A, those things should come into one partition. So that's where it is. Then join is performed locally with each partition within each partition. So this is the reason it'll take a while. Next, join requires correlation co-location of matching keys. Requires key line. Join requires collocation of matching keys. Requires repartitioning. That causes shuffle. Simple answer we can say that. Okay. Small correction in your answer. Not exactly it will collect. So shuffle will happen. Okay, instead of collect, it'll we can say that shuffle will happen because of that. It'll okay. Next, a quick check. Which join can avoid shuffle? Large table join, small table. I think second one will avoid the shuffle. I believe so. Let's see because yeah. Why no shuffle there? If one table is small enough, Spark can broadcast it to all executors because each executor join locally within its partitions of the large table. So, okay. So, to explain this in a simple way, like maybe you might have aware of this particular word broadcast. Like for example, if any live program is happening, like for example, our live, not our live, maybe BBC or any other news channel is broadcasting something, some news in to their users, it will broadcast directly to their television. So the same way, the program is defined, program created by the BBC, it is broadcasting to your local machine. So that's the same way each executor joined locally as Spark broadcasts those small table to each of its partitions. So the join will be little easy. So name of the optimization is called a broadcast join. Is one of the important question actually. Okay, yeah. Mm, okay, the code is like broadcast. We need to import as the function. From the functions we need to import broadcast and join broadcast slash df dot underscore small, which is a small table on key id. So both can be matched in as Spark broadcast this particular small table into each of the partition. So it will join that particular large table in each partition. So it won't be any shuffle. Shuffle both tables. So the join perform here is a locally. So that's why. Okay. When would a broadcast join fail or not be useful? If the broadcast table is large, then the join will be failed. So let me directly answer this. Let's see what prompts, what GPT will answer this. Yeah, you're on the right. Let's make precise, man. Okay. I think I may need to work more on my wording as actually. Broadcast gen not used when the small table is actually too large to fit in executor's memory. Broadcasting would cause memory pressure. Oh, oh. So Spark avoids it and fails back to shuffle join. Falls back to shuffle join. Okay. One important upgrade. Interview code. Okay, what is that? Spark usually decides this based on a threshold. So which is broadcast join threshold. Its default is 10 MB. It can be vary. Okay. Yeah. So if it is table is too large and it cannot fit in executor memory, then you need to go back to shuffle. Okay, so now my question is like, okay, let's before answer. Okay, let's answer this question, and of course, you can ask the question as well. Hmm, uh, if Spark does shuffle join, which side gets shuffled? Hmm, below threshold is the broadcast, and above threshold is shuffle join, but shuffle join will happen internally. Okay, I am still confused about the above question actually, and I thought I exclusively need to do a shuffle join instead of the Spark itself will do, even though I specified the broadcast in the code itself. So this, even though if it is a large table, then Spark automatically understands that a large table and go back to the shuffle join. How it works, I just want to know. So I think my question is valid here. So to okay, let me give it to the GPT, and meanwhile we can discuss about it. So my doubt is like, so when I since I have specified the code like broadcast, and unfortunately, this df small is not a small table, it's a huge table, and it is not fitting in the memory based on the parameter we have specified, which is broadcast. One second. See, this is the threshold we have mentioned. This is not fitting uh, in that broadcast level, so broadcast threshold. So I thought I exclusively should not use broadcast. Spark itself, no, Spark it internally won't define this particular instead of broadcast to the shuffle join. I thought I need to exclusively mention, so that's the reason I was asking this question. Okay, so what? Okay, let's go back and think what I have asked. I'm still confused about the above question actually, and I thought I exclusively need to do a shuffle join, except the Spark itself will do even though I specified the broadcast in the code itself. So even though if it is a large table, then Spark automatically understands it's a large table and go back to shuffle join how it works. I just want to know. Okay. So if Spark automatically chooses broadcast, it uses the size threshold. Okay. If you directly give a broadcast hint, Spark will try to broadcast regardless of the threshold, but a hint is still a strong suggestion, not an absolute guarantee for every case. Okay, separate these two cases. Okay, case one, no hint means I'm not specified any broadcast specification. Okay, of course I have mentioned broadcast join threshold limit. That I did. Spark checks the estimate table size. Okay, small enough. May pick broadcast join. Too large. Usually picks a shuffle based join instead. Okay, internally it will happen. Next, you write broadcast df small or use a broadcast hint. Okay, Spark is told use broadcast for this side. No, again it's confused. Okay, what it says. Okay, you write exclusively broadcast. Okay, use broadcast for this side. According to the Spark docs, that side is broadcast regardless of so and so. Then why do people still say large broadcast can fail? Because the threshold and the actual memory feasibility are different things. It's still giving me a confusion now. Okay, let's read more and we may understand a bit. Uh, think of it like this: broadcast join threshold equals to rule of automatic selection. Okay, executor memory, whether the broadcast is actually practical or safe. So if you force broadcast on a large table, Spark may still attempt it, but that can lead to a poor performance of memory problems. Also, Spark talks say a hinted strategy is not guaranteed in all situations because some strategies do not support all joint types. Okay, best mental model is threshold controls automatic choice. Hint, you can override that automatic choice. Memory and joint type still matter in real execution. Okay, so threshold controls automatic choice. Mhm. Hint can override that automatic choice. Like, okay, okay, got it. Memory and join type still matter in real execution. Okay, point number one says you mentioned you specified threshold limit. So, of course, the default threshold limit is also there. What is the default threshold limit here? Okay, let me go back and see what is the default threshold limit. Default threshold limit 10 MB. Default is 10 MB. Okay, so if you exclusively know that's a small table, better hint it. Okay, and if you're not aware the table details and you just based on the threshold limit you just specify, so then Spark will automatically decide based on the size. Of course, any which way, memory and join type still matter in real execution, of course. Okay, let's learn this with an example. In this case, tiny example from spark.sql.function import broadcast. Of course, I'm imported broadcast and small df I have specified, and of course broadcast exclusively I mentioned. Say this broadcast small df. Spark will try to honor that even if it is above the auto threshold. Okay, Spark still tries. Okay, without a hint, Spark uses size rules to decide broadcast. With a broadcast hint, Spark tries to broadcast that side even beyond the threshold. But success still depends on execution realities. Okay, it may fail, it may not fail, but it will try since you have hinted it as a broadcast. If could able to pull off based on the memory limitations, then it will perform the join in a threshold mode only and it will complete it. And if you could not able to complete it, then it will fail because of the memory reasons. Okay, and that's a good understanding. Now can you check if you do not use a hint, what setting mainly controls whether Spark auto picks a broadcast join? Broadcast memory setting. Broadcast memory setting. Yeah, auto broadcast join threshold. I don't remember that exact thing. Okay, fine. Why your answer is slightly off? It sounds like executor memory, which affects. Yeah, auto broadcast join threshold. Auto broadcast join threshold, which will be a 10 MB default size. Of course, you can specify more. Clean distinction threshold setting decides whether to choose broadcast. Memory decides whether it will actually work well. Quick reinforcement is one table. If table size is equals to 5 MB, threshold equals to 10 MB. Spark will auto choose broadcast, of course. Now let's go back to your earlier question. You paused there. Okay. If Spark uses shuffle join, which side gets get which side gets shuffled? Both sides. I think 3 is the correct answer. Both sides. Yeah, both sides. Now let's make a crystal clear. This is top interview question. Okay, fine. Why both tables are shuffled in shuffle join? Spark needs some keys together, but both tables are randomly distributed. So Spark does repartition left table by join key, right table by join key. Both sides are shuffled to matching keys land in the same partition. So separately, each table will repartition based on the join key, and of course they shuffle based on the matching key. Mental model is like before: A1 B1 C1, A2 B2 C2, and shuffle by key partition all A's, partition to all B's, and partition to all C's, of course. Yeah, we have now covered lazy evolution, means until and unless the action is started, it won't perform any transformation. That is called lazy evolution. Next, directed acyclic graph, which will be the plan how to execute a particular end-to-end end-to-end chunk of a code that will have stages and tasks. Partitions means chunk of distributed chunk of a data, different chunks of a data, so that to achieve the parallel computing, that's the best feature in the Spark. Next, shuffle depends on the grouping function or matching key in each partitions. The data need to be shuffled. When you do repartition, the shuffle will happen. Any grouping thing, then shuffle will happen. Broadcast versus shuffle giant, as we already know, you can mention a hint of a broadcast where it will forcefully try to broadcast it, and the memory availability is there, it will perform. Maybe the performance will be slow here, but still it will perform, else it will fail. And if you go without any hint of a broadcast, based on the broadcast parameter like broadcast shuffle, oh, I forgot again, auto broadcast, yeah, auto SQL, auto broadcast join threshold, auto broadcast join threshold limit. Based on the auto broadcast join threshold limit, it will choose either of broadcast or shuffle join internally. So let's begin with data frame operations and real work now. Okay, he's asking write the PySpark code here. Okay, so let's end this session as an intro as of now, and let's continue in the next session. I'll stop sharing, and thanks for watching my session. Please try to subscribe. Thanks a lot.